Hello, welcome to STEM with Mr. Duda, and in this series I'm going to be talking about sensors and exactly how they work and the information that they are sending from the sensor to your device. And in this case I'll be showing you through an Arduino. So stick around. Hello. All right, so today we're going to be talking about the linear magnetic Hall sensor module, and what it's able to do is actually detect magnetic fields, which is pretty cool. Now this one has the same as the microphone, where it has this potentiometer. You need to turn this counterclockwise once you've wired it, and I'll show you how I have it wired, but once you've wired it, you need to make sure to turn this counterclockwise until this LED turns off. Then you can turn it just a slight bit, just have it slightly off, and then when there's a magnet near it, the light will turn on. Okay, we hook it up the same way we did for the microphone. Is that correct? Yeah, awesome. So it looks just like our microphone. I actually just kept my microphone wires and dropped this into my breadboard. So we've got digital output on number 1, the voltage in on number 2, 3.3 to 5 volts, 3 on ground, and then analog output. And in my case, what I ended up doing, I ran, and I'm going to show you what I ran because I thought it was interesting. I think I know exactly why. I haven't spent a lot of time on it, but I was looking at the code here. Let me see if I can make this bigger for you. This is the code that they provide, that Algoo provides for this. And I noticed there's no delay on this. And so I don't know if that's why, but when I ran it, it sure did not work well. And I decided, because it was wired the same and because it pretty much works exactly the same way, that I would just use the coding from the sound sensor example. And that worked perfectly. So if you did not see the sound sensor example, here it is. Basically, we have analog pin, digital pin. We make some value called analog value and digital value. That one doesn't necessarily matter in this one. LED 13. I guess it does because it lights up the LED. And then we start our serial. And basically what happens is I've got, and let me make this full screen for you. I've got my setup right here. All right. So we have the Arduino and we have everything wired in. And here's my Hall sensor, and I've got a magnet from the inside of a hard drive. That's all I really had. And you'll notice when I get close to it, and let me see if I can show it to you, the LED will light up, right? And that means it's actually detecting the magnetic field. All right, and so what we can end up doing is we can use our serial monitor, but that's not the best way to do it, just like last time. Instead of doing the serial monitor, we are going to do the serial plotter, which actually makes a graph of the values that are received from the serial port. So let me change to that so you can see it. The values, which don't seem to be running right now. Maybe I didn't upload it to my board. I did have that other sketch on there, so I'm guessing that's why. So I just uploaded it to my board, and you'll see it's outputting values now. And I want to make sure it's on my screen. Good. And now I'll put the magnet near it, and you'll see that it is highly affected by it. Now, I'll show you now why it went up that one time and then it goes down the rest. I'm not sure, but you can sort of see the interaction with it, depending on the distance I am. Now, obviously, it's not detecting this magnetic field very far away. This is a very cheap Hall sensor. I'd imagine there are Hall sensors that are much better. But that is how it works. Now, if you want to see it in the normal serial monitor, you'd just be seeing numbers. This looks like they're all about 500 down to 300. And if I get it really, really close, it'll stay down. If I get it far away, right? So that is it. If yours isn't working, you need a potentiometer on there. You might have to wire your own if you don't have a nice module like I have. Yeah, so hopefully that showed you something. Hopefully you learned something. Feel free to subscribe and have a wonderful day, everybody.